Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I'm going to do is I'm going to start learning Scala. I want to learn Scala just because I'm learning a lot more about big data recently. If you've been following me on LinkedIn, you know why. But basically, one of the things about the data processing framework Apache Spark is that you can generally write scripts for Apache Spark in one of three languages. Python, I know Python, and I could go focus on learning Spike with Python. But there's also, you can also use Java and Scala. And it seems like a lot of things revolve around the Java runtime in big data, mainly because of one of the frameworks for storage called Hadoop that's used. So Hadoop allows you to store lots of data. Instead of having to get a big, really expensive computer to store a lot more data, you can get like a lot of, whatever hard drives and a lot of little, lower powered computers, and they could act as one big cluster that saves the data as like a group. And each of these computers are called a node, and this is all managed by the Hadoop software. And the Hadoop can allow you to write different, and it's all done through the Java ecosystem. But again, it just means Java bytecode. So any JVM language, any language that can be compiled through Java bytecode, theoretically can handle it. There's more out-of-the-box support for so Java, of course, but that could also mean Kotlin, Scala, Ballerina. There's a few other ones that are languages that have a variation that can compile the Java bytecode. I even think some of the languages like Ruby and Python have dialects that can then compile to Java bytecode. But again, there's more support for Scala as an alternative to Java in this space. So I want to start learning Scala because I think it would be useful for my new endeavors. So basically, to get set up with Scala, first I had to do is, not this one. Actually, no, that was the right place. First I did is I installed Java. I had Java 11 already. So if I do like Java -- version, you'll see I have Java OpenJDK 11. I did install 17, which is the newest one, just because I couldn't quite figure out how to swap the versions to make it, upgrade 11 to 17. I installed 17 separately and had to bind it to this command. So this is not something that this is not how it would work out of the box. But so I do have a version of Java 17. I bound it to the alias of Java 17, just using standard bash aliases. Okay, so I just did the alias over just referring to the executable and just through the keyword Java 17. Okay, but the idea is you have to have a version of Java installed. Then I installed Scala. Okay, so Scala C -- version. Oh, that's right. This is it uses one dash for the flags. Dash version, so 2.11.12. So that's what I got. So that's the first thing you want to do. You could also use a REPL if you just wanted to kind of follow along with these videos. I have done a video with Scala in REPL before, but now I actually have it. And then I downloaded the Scala extension. So Scala VS Code, the Scala syntax extension, and then that should get you to pretty much where I'm at. Okay, so Scala works with Scala files. And again, if you've ever used any kind of Java-based language before, basically the way it works is very, very object-oriented. And that's one of the cool things about Scala. It's supposed to be sort of like a weird hybrid of functional programming and object-oriented programming. So it's very object-oriented because it's in the Java world, but also has a lot of very functional stuff going on. Okay, but basically generally what happens in sort of Java-based programs is that every script in itself is a object or class. So, okay, so if this was Java, this would be a class. So essentially what happens is that your actual script, your actual program is in itself a class, and basically its main method. So I'm assuming you know some programming already and you're familiar with things like what a class is and object-oriented programming. If not, I would recommend watching my JavaScript series. My JavaScript series is much more designed towards someone with no programming background. So basically the idea is that the class that's being run, that's the program, is given a main method. The main method is the entry point for the program. Okay, so this is similar to if you've ever done C or C++ or Go or Rust, where you start off with a main function. The only difference is that this main function is not just a standalone function, but a method of a class. And generally the class should have the same name as the file, Okay, so and then basically once you compile it, so you get these class files. So these are like the Java bytecode representations that get run inside the Java virtual machine. Because the idea behind Java was write once, write anywhere. So the way it works is that you write your code, and instead of your code compiling to machine language for that particular hardware, so for like a Intel chipset, Windows operating system, or AMD chipset on a Windows operating system, or a Intel chipset on a Mac operating system, and compiling for that particular sort of environment, because that was always the issue. You had to kind of keep compiling things over and over again, and having to update your code depending on what environment you were in, made it really hard to create cross-platform desktop software. The idea behind Java is that everyone would install the Java runtime, and you would just write your code, compile it to Java bytecode, and distribute it that way, and then people would basically be able to run that code through the Java runtime on their computers. Okay, so it didn't matter if it was a Mac or Windows or Linux or wherever. Write once, run anywhere. Works well for for the purposes of desktop software. Nowadays you have like Dart that kind of does that for like mobile, but cool stuff. Okay, so basically what happens is Scala is just another language that compiles to Java bytecode. Java compiles to Java bytecode. Ballerina compiles to Java bytecode, and there's several other languages. Let me just actually do a quick search on that because it's an interesting topic. JVM, Java Virtual Machine Languages. Okay. Let's just give me like a list. No, this is just like some course list of JVM languages. Here we go. Oh yeah, Groovy. I always forget about Groovy. And Clojure. Oh yeah, Clojure. Clojure is another like functional one. So these are other languages. Kotlin we've mentioned before. Then here's like just a bunch of other languages that have implementations in Java bytecode. Okay, so there are versions of Python. There are versions of all these languages that can compile to Java. And here's some more like more obscure like languages that compile to Java bytecode. Okay, so it's a whole sort of universe into itself. Okay, so just so you can put the context of like, what are you doing when you use Scala? Okay, so again, your program is within, essentially, within this main function. So first thing you always want to learn is basically how to print text to the screen, because you need that for logging, for debugging, etc. So in this hello world Scala, we see like the basic idea. It's just this print line function, and we can pass what we want. That works. And again, what I can do to compile it, I would type in Scala C. That's the Scala compiler. And I would say Scala C. Well, I'm in the wrong file, so let me just go CD. Oh, no, I'm in the right folder. Okay, Scala C. Hello world.scala. And Scala stands for Scalable Language. That's why it's called Scala, because the idea is it's supposed to be like a language that scales using those functional techniques. So Scala C, hello world.scala, I hit that, and what that does, it compiles it to the Java bytecode. Okay, and then I can just run it again by using Scala C, or actually I think I could just type in Scala hello world, and see that's just going to run that Java bytecode. Okay, I might be even able to run it just with a Java command. Let me just try that out. Java hello world. Just see what happened there. Main thread Java, no class found definition, Scala predef. Okay, so yeah, you still need to run it with the Scala command. Cool. Because I don't think here we just compiled it to like this class file. I think there's another type of file you can run. You can compile it into. I forget what they're called. Okay, but yeah, you get the idea. Now what I want to do is I have this scratch Scala just to kind of try different things. So first thing I like to do is just declare variables. So there's two types of ways of declaring variables. I could declare a variable with the var keyword. These are mutable variables, okay, meaning I can change it. So I can be like var num, which is an integer. Let me just see if like that's the, here we go, the data types. Let's take a look at the data types. Int, okay. So var int equals 5. And then what I'll do is I think I need semicolons. Okay, print line, and then I would put num. And then we'll say num equals 6. And then we'll print line again, num. So now let me cd into the Scratch folder, cd into Scratch, and then do Scala C, scratch.scala. So I'm going to compile that file. Okay, so see that file's been, oh, because the class is still called hello world, I should probably fix that. Scratch, because it should match the file name, so that's confusing. So Scratch will be the class. Let me delete this, so that way that doesn't confuse me later. And let me just do that again. And there we go, so you see Scratch. And now if I run that, Scala Scratch, see, it works. First I created a variable that was a value of 5, and then I changed its value and I printed it again. Now, val, if I do val, it's immutable, meaning I cannot change it. So this is more like const if you're using like JavaScript. So now in this case, I should throw an error. So let's try compiling it again. Should throw me an error. Right there. Reassignment to val, because again, val means immutable. That means no reassignment, so that's not going to work. So I have to get rid of these 2 lines, which we can comment out with just double slashes. Okay, so let's compile that, and then I will run it. And that works. Okay, and again, you can type it. You don't have to type it. I could also just, it could be dynamically or inferred, because basically it'll infer that since the number on the other side is a integer, that the type of this variable is an integer. 5. Now there are certain situations where you want to definitely be explicit even though you're assigning it a value. So for example, maybe I'm assigning it to number 5, but I really want it to be a float. So let's see here. If I do that, and I think I have to do that as like a float. And now let me just try this again. Let's compile it. And you see, because I typed it as a float, it appears as a float, a floating point number, when I print it. But had I just, asked it to be implicit, it would have come up with like an integer because I didn't use a decimal there, so it wouldn't have inferred a float. So there are times you want to be explicit, a lot of times you don't have to be, which definitely saves a lot of code, saves you writing a lot of code. Cool. And again, there's all these different types. So again, there's like unit, which in different languages always generally means like no value, usually used for like functions that don't return a value when you're typing them. Booleans, true or false, string, which is a sequence of characters. Doubles and floats are just different types of decimal point numbers, just like a different level of how far the decimal point can go. Now let's talk about signed values. Signed values means that there can be a negative sign in front of them. So there could be a negative versus a positive number. An unsigned number always means that there's no sign, so it's only positive numbers. So you can generally, in the same space that it would take you to fit a signed number, you could fit a much larger unsigned number because you don't have to save that plus or that minus, possibly make room for that negative symbol. Just in case you ever wondered, what does this mean by signed and unsigned integers? Okay, it just means, do we have room for a possible minus? Okay, but yeah, so those are how that works. And then, as you already can kind of see how you define functions. So I could define another function. We'll just say define hello. Okay. And I'm just going to say print line hello. And I think I should be able to just use the method as is because it's part of the same class. So I don't think I have to write like this.hello or anything like that. I can just do hello. We'll find out in just a moment. So let's try that out. And then let's see if I run the code and see it works. Okay, so I can just define additional methods on this class, and they become other functions I can use within what's going on within my main function. And again, this is a very similar pattern so far to what you would have seen in Java or C#. That all sort of follow that sort of like very object-y way, where basically your program is an object with methods, and you have a main method, and so forth. So we've seen here that I can define variables, I can write a function just using that def keyword, and they're all just methods of this particular class here. I could even write other classes. Typically, you probably want to write that in another file. Usually, it's usually one class per file, and you import them as needed. But yeah, so that's an introduction to Scala. So the goal here was to kind of get you setting up your environment for Scala. So installing Scala in Java, and then getting the extension for VS Code, and just kind of writing your first couple basic programs. So my name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.